In the last lesson, we added and subtracted rational expressions with like denominators. In this section, we'll learn how to add and subtract rational expressions when the denominators are not the same. Now let's get into adding and subtracting rational expressions that have different denominators. Simplify this expression, write your answer in lowest terms, but we're allowed to leave it in factored form in the end. If I have denominators of 3x and 4x, I have to find the LCM. It's easy enough to see it will be 12x. If you're not sure of this, we can always come to the side and find the prime factorization of those and use the LCM strategy that we had. We have 2, we have 3, and we have x. 2 shows up twice, 3 shows up once, x shows up once here and once here. We can only use it once. So when we multiply that, we have 12x, the LCM. Now my job is to turn 1 over 3x plus 3 over 4x into denominators of 12x. How do I do that? Here, I would just multiply by 4 over 4. Because that turns the denominator into 12x. So I multiply 4 times 1 and I get 4 on the top. Here, if I would multiply by just 3 over 3, I would get 12x on the bottom and I'd get a 9 on the top. Now that I have common denominators, I can go ahead and combine those. 4 plus 9 over 12x. And 4 plus 9 is 13 over 12x. That is the most simplified form of the answer, so we can go on to our next problem. Here we have different denominators, n minus 1 and n plus 1. Do you agree that n minus 1 and n plus 1 are already factored? So the LCM will be the product of n minus 1 and plus 1. How did we turn 5 over n minus 1 into a fraction with a denominator of n minus 1 n plus 1? We see that we already have the n minus 1 factor. We need to multiply n and n plus 1. n plus 1 over n plus 1 then. That gives me the denominator that I need. And the numerator will be 5n plus 5. We'll want to go ahead and multiply this out because we're going to combine like terms when we get the denominators the same. Over here, how did I turn a denominator of n plus 1 into this? I multiplied it by n minus 1 over n minus 1. So n times n minus 1 is n squared minus n. Now when we add our fractions, we'll have 5n plus 5 plus n squared minus n all over n minus 1 n plus 1. Let's combine like terms in the numerator. So we get n squared plus 4n plus 5 over n minus 1 n plus 1. And the numerator does not factor. If it did, we'd want to go ahead and factor it to see if we could cancel anything. In this problem, I have an x minus 3 and a 3 minus x. I could go ahead and find the LCM of those, but the problem process would take a lot longer. Do you recognize what those binomials are? Remember, they're opposites. While we have a positive x over here, we have a negative x there. While we have a negative 3 there, we have a positive 3 there. It's quite easy to doctor this up just by multiplying by negative 1 over negative 1. When we do that, it switches, so we have a negative 6 on top and negative 3 plus x on the bottom. This is the same as having an x minus 3 on the bottom. moving the terms around so that the sign in front of the number stays with the number. Then I can go ahead and combine the fractions. 3 plus negative 6 over x minus 3. 3 plus negative 6 is negative 3 over x minus 3. And that's the most simplified form of that answer. We can't cancel the 3's. Remember, you can't cancel terms. You can only cancel factors. This problem has the denominators factored for you already, so we can go ahead and jump into the problem. Can you see what the LCM is? It's going to be y 2y minus 1. Y 2y minus 1 over here. Now this fraction did not change the denominators, so we don't need to do anything with the numerator. Over here, we're missing a y, so we'll multiply a y in. We get a y there. Now that we have common denominators, I can go ahead and combine 2y plus y all over y 2y minus 1. 2y plus y is 3y all over y 2y minus 1. You can keep that in factored form, but you need to recognize we can cancel a factor here. So you'll want to make sure and do that. The y's cancel, and then we're left with 3 over 2y minus 1. We could cancel those because they're things that are being multiplied. Y is multiplying the 3 on top. Y is multiplying the binomial 2y minus 1 on the bottom. So since they are factors, we can cancel them and simplify that fraction. With this example, I'll need to factor the denominators. 3 over 2a minus 2 plus 3 over a minus 2 minus 5 over 2a. Now we need to find the LCM. I'm looking at the numbers 2a and a minus 2 as my prime factors. How many times does 2 show? It shows once here, none here, once here. So I'll use it only once. A shows up no times here, once here, once here. I'll use it once. A minus 2 shows once, and no times. I'll use it one time. So 2a, a minus 2, is going to be my least common denominator. Now, looking at this fraction, how did I get the denominator to turn into 2a, a minus 2? It looks like it's missing the factor a. So we can multiply that factor in on top and bottom, and it makes the numerator 3a. Looking at this denominator, it's missing a 2. So I'll need to multiply a 2 over 2 here. That makes the numerator 6. With 2a, I'm missing a minus 2. So I'm going to multiply in a minus 2 over a minus 2. That gives me a 5a minus 10. Now we're ready to go ahead and combine the numerators. 3a plus 6 minus 5a plus 10. How did that become a plus? Remember that we're subtracting all of the numerator. We want to make sure that we're not only subtracting the first term, but every other term in that numerator. So when we subtract negative 10, we get a positive 10. You'll always have to watch when you're subtracting those rational expressions and make sure you don't have one of those going on. Now I'm ready to combine my like terms. So I have a negative 2a on top and a plus 16. And in the denominator, I have 2a, a minus 2. Can I take out any kind of common factor here? Sure. I'll take out a 2. So if I take out a 2, that gives me a negative a plus 8. And that's all over 2a, a minus 2. And it's a good thing I factored out the 2 because now I see that I can cancel out this 2 and this 2, and that leaves me with a negative a plus 8 all over a minus 2. Go ahead and try the homework and let me know if you have any questions.